picture this. You're out in space. No helmet, no oxygen tank, not even one of those shiny silver blankets. Maybe you fell out of a spaceship. Maybe you were thrown out for eating someone else's freeze-dried ice cream. The details don't matter. What matters is that now it's just you, floating in the void. The first thing you'd notice is nothing. Space is silent. No air to carry sound, no wind, no background hum, just the eerie stillness of the universe. The stars around you don't twinkle. The sun is an impossibly bright, painful spot. And your ship is getting smaller every second. Your brain will immediately demand oxygen. Unfortunately, you've only got about 15 seconds of useful consciousness before you pass out from hypoxia. That's because the moment you're exposed to the vacuum, the pressure around you drops to almost zero. The air in your lungs wants to expand and escape, and if you try to hold your breath, it could rupture delicate lung tissue, forcing air bubbles into your blood. That's called an air embolism. Spoiler, you don't want one. The counterintuitive survival tip? Exhale. Let the air out as you're thrown into space. It won't save you for long, but it'll stop your lungs from popping like overinflated balloons. Your next big problem is temperature. People think space is instantly freezing, but that's not entirely true. Without air, heat doesn't transfer quickly. There's no icy wind to steal warmth from your body. Instead, you lose heat through radiation, which is a slower process. In the shadow of a planet or spacecraft, you might actually freeze over minutes or hours. In direct sunlight, though, you're under constant attack from unfiltered solar radiation. Imagine standing in front of an industrial heat lamp that also gives you a massive sunburn in seconds. Speaking of radiation, in space, there's no atmosphere to block ultraviolet rays or cosmic particles. Within moments, your skin would start to redden and burn. If you're near the sun, you could also get a potentially lethal dose of radiation in just a few minutes. Lucky you? Then there's the water in your body. No, you won't explode like a movie villain. Your skin is strong enough to hold you together. But the liquids on your tongue and the moisture in your eyes will start to boil away. Your saliva would fizz, your tears would evaporate before they even have a chance to roll down your cheek, and your eyes would feel painfully dry. At the same time, the lack of pressure causes your body to swell, not like a balloon, but enough to make your face puffier than a marshmallow in a microwave. What happens next depends on the clock. First 10 seconds. You're conscious, but your vision is tunneling and your movements are clumsy. You feel disoriented and can't breathe. Around 15 seconds. You lose consciousness. There's no dramatic gasp. Your brain simply shuts down to conserve what little oxygen is left. 1 minute in, your skin is sunburned on the side facing the sun, and ice crystals may be forming in your mouth and nose on the shaded side. Your heartbeat slows. 2 minutes in. Permanent brain damage starts. Your body is in critical condition, and without rescue, you're done. 3 minutes, the point of no return. Even if someone pulls you into an airlock now, it's extremely unlikely you'll come back. If, and it's a big if, someone manages to get you back into a pressurized environment within about 90 seconds, there's a chance you could be revived. You might suffer some swelling, burst capillaries, and possibly some hearing or vision loss, but you'd live to tell the story. And you'd have the ultimate, craziest thing that happened to me anecdote for the rest of your life. In summary, you could technically survive in space without a suit for about 90 seconds before your chances drop to zero. Not enough time to finish a text message, but just enough time to regret every decision that led to this moment. And remember, in space, no one can hear you scream, but they can see you flail around like an angry inflatable tube man until you drift off into the cold, endless night.